So this is the sample circuit that I gave you on the back of last week's syllabus. Um, I went through and solved it, and I want to go through that. Hopefully we'll be able to do that in class also. So in this case, 54 total volts. Each resistor is labeled. The diagram's a little wonky, but that's okay. And this is a complex circuit for sure. So I like redrawing this as indicated in here as a simplified version. It shows that there's two total paths between B and E. Actually, there's 5 total paths between B and E, but I'm simplifying it to 2 here. So this is a 3 ohm resistor. These two are 6 ohm resistors in parallel, so that'll add up to 3. 3 plus 3 is 6 total ohms in the middle branch. This is 12, 12, 12. 1/12 plus 1/12 plus 1/12 is 1/4. That's 4 ohms up top. And then that's all that messes in series with this 2 ohm resistor R11. So the outer branch also has 6 ohms. So if I want to figure out the total resistance of the circuit, I do 1/6 plus 1/6. That comes out to 1/3, so that's 3 plus 4.5 plus 1.5. So that's kind of how I would simplify that out. So at any rate, these questions are things where the top 10 I can probably do while looking at this. The bottom 10 I'll have to kind of toggle back and forth. So let's take a look at the answers there. And then the answers are down there for the other ones. I've tried to show some work, but again, there are sometimes multiple ways to do this. So going back up to the top 10, for R3 and R4, the total resistance of those, I simply add the reciprocals, a 6 plus a 6, flip it, I get 3. For 2, 3, and 4, I'd add this 3 with that 3, since this component is in series with R2, and that becomes 6 ohms. Combined resistance of 5 and 6, well, those two are in series with each other, so that's 12 ohms. What would a multimeter measure from B all the way to D? So that's really this total resistance, which means this question is the same as question 5. So if that's 12, that's 12, and that branch is 12. 1/12 plus 1/12 plus 1/12 is 1/4. That comes up to 4 ohms. Looking at this, you can see why the resistance from B to E would actually be 3 ohms. If you're not looking closely, most people would say 6 because they're going to look from B to E straight down this branch. But all these possibilities also lead from B to E, so you have to take them into account. So 3 ohms from B to E. The total resistance of the circuit, 4.5, plus 3 for all this, plus 1.5, gives us 9 ohms. Total current is 6 amps, 54 volts divided by 9 ohms. So therefore, if you have 6 amps total current, when it splits off, you can never end up with more than 6 total amps going in the direction around the circuit at any one time. So this plus this plus this plus this plus this have to add up to 6. They can't add up to more than 6. The current through R2 and R11 would have to add up to 6. And if you look at how the resistance is split, the current is going to split evenly. If it wasn't even, you could figure that out as well. So I know that I've got 3 amps going through the middle branch and 3 amps going through the outer branch. So in this case, the voltage drop across R1, 6 times 4.5 is 27 volts. The voltage drop from B to E, well, from B to E we had 3 total ohms times 6 total amps, so that's 18 volts. Or if you know that there's 3 amps going in each direction through each of these branches, 3 times 6 is also 18 volts. Going on now, the current through R2 is 3 amps. We talked earlier about how that split evenly. The potential drop across R3 here, you could treat this either as a single 3 ohm component or a single 6 ohm resistor. If it's a 3 ohm component, 3 amps go through that, and so that's 9 volts. However, the current will split evenly through R3 and R4, so only 1.5 amps will go through R3. 1.5 times 6 also gives you 9 volts. The current in R4, 1.5 amps, again it's split half each direction from when it enters at part C, or at node C. The current in R4, I just said that was 1.5 amps. The current through R11 would be 3 amps. That's because that's the half that goes through this outer branch. For 15, the voltage dropped from B to D. Well, you could think of 3 amps total times 4 amps for this whole component. Or you could recognize that the current's going to split 1 amp, 1 amp, and 1 amp, and therefore 1 times 12 ohms would give you 12 volts. So either way, I think it's easier to think of the whole equivalent component. The voltage drop across R11, well, I've got 3 amps going through that, 2 amps there, that's 6 volts. Notice these two equal 18 volts, which is what I got up here. Current in each branch from B to D, 3 amps divided by 3 paths of even resistance. If they were not even resistance, I could take the voltage across from B to D divided by the resistance in each branch, and I get a different current in each branch. The sum of the potential drops across R9 and 10, 12 volts. That would also be the sum across R5 and 6 and across R7 and R8. Potential drop across R7, 8 ohms of resistance times 1 amp. And then finally, the sum of the potential drops in the external circuit had better be 54 volts because that's what's provided. The sum of all currents flowing from B to E better be 6 amps because that's the total current. So hopefully this helps a little bit. There's a lot going on here, but it helps to go through it methodically. I probably could have drawn other pictures than just this as well. Probably could have drawn a 3 ohm equivalent resistance out there. So hopefully that helps.